Okay, good morning, guys. Today we're going to be moving on to lesson 8.2, day 1. We're going to cut this in half. We're actually looking at sums of arithmetic sequences. So what does that mean? That means we're going to take a whole cluster of numbers, and rather than taking our calculator and add them one at a time, we're going to find out a nice little shortcut way to throw them all together if they are an arithmetic sequence. Okay? And that's today, 8.2. Tomorrow we're going to finish this lesson up. So after today's lesson, you will be able to do the first 4 problems in your homework. Tomorrow is all applications, or all word problems, and we'll go through that video on Thursday. And then you'll be able to do all your homework. So bottom line here, there's a warm-up on this problem in lesson 8.2. And what I want you to do is identify the sequence of number as arithmetic or geometric, then find the next two terms in the sequence. Finally, write an explicit formula for the sequence and find the requested term. Okay? What do you mean? Like right here, we want to find the 7th term. I don't know if it's a sub 7 or g sub 7 because I don't know if it's arithmetic or geometric yet. So why don't you take a few minutes, hit pause, and go through there and do this. And you know what? I'm going to challenge you to not touch your calculator. You should really not need it. Go for it. And I'm going to come back and this is going to be filled out. Okay, so first and foremost, I noticed that because my numbers actually here, they were alternating from positive to negative, I really knew it couldn't be arithmetic, and it had to be geometric. But finding r, remember, all we got to do is we got to take the first term times, what is going to give me the next term. So what that means is r is actually going to be 8 over negative 16, which would be negative 1/2 is my r. So negative 4 times negative 1/2, well, that's positive 2 times negative 1/2 is negative 1, okay? So then that gives us our explicit formula because we know the first term, we know r, and we know it's going to be raised to the n minus 1 power. That's my g sub 1. And what they want us to find is they want us to find g sub 7. So g sub 7, hopefully you don't need your calculator, that's going to be negative 16 times negative 1/2 to the 7 minus 1. That's going to be the 6th power. And what I notice here is I know this negative is going to be to an even exponent, so that's going to be 1 over 2 to the 6th power, and I know that's going to be a positive number. And here, that number 16, that's kind of a unique number that is 2 times 2 times 2 times 2, or 2 to the 4th power. That's going to be over 1, and I can reduce these 2 to the 4ths with the 2 to the 6th. That's going to give me the opposite of 1 over 2 squared, so I should be getting negative 1/4 for my g sub 7. Okay, the next one is I can see here, well, it's kind of, negative 7 to 1, so what is that? That's like plus 8, plus 8, plus 8. Oh, it's got to be arithmetic because d is 8. So I know my first term here, is negative 7 plus my d times n minus 1. Hey, that gives me my explicit formula. And we want the 40th term. So we want a sub 40. Well, a sub 40, what's that little rascal going to equal? It's going to equal negative 7 plus 8 times, that's going to be 40 minus 1. That's going to give me 39 in there, isn't it? And 39 times 8, I think that's 312, because that's 72 is 24 plus 7 is 31 plus negative 7. So a sub 40 equals negative 7 plus 312. I think that gives me 305. So a sub 40 is 305. And we got to it really quick there, okay? So the goal of today is we're obviously not doing group exploration here because, you're at home alone or you have friends over, I don't know. But today our focus will be finding the sum of the terms of a sequence instead of individual terms, okay? So that means we're going to have a whole list of numbers like we did. One of the most famous stories about arithmetic series relates to one of the greatest mathematicians in history, Carl Friedrich Gauss. his elementary teacher asked the class to find the sum of the first 100 positive integers, and within seconds, this little rascal knew what the answer was. So let's explore to see how he got the answer so quickly. So the first 100 positive integers, 1, 2, 3, and that's adding them all together. And just so you know, we have been talking about sequence, okay? And this is a series, and this is a series because all of my terms are separated by addition signs rather than a comma. If it's a sequence, the numbers are separated by commas. That's the difference between a sequence and a series. And what he did is like, oh, he's regrouping the numbers. Well, if I take all the numbers from 1 through 100 and I add them together, what little Carl did is he said, if I group the first term with the last term and I add them together, I'm going to get 101. And if I group the second to the second term with the second to the last term and I add them together, well, wouldn't you know it, I got 101. In the third to the last, wouldn't you know it, I got 101. And as I'm pairing, okay, the middle two are going to be 50 plus 51. Notice they're 101. Okay, so all the groups he's doing there, he's adding them up to 101. Well, if he had 100 terms and he added 2 of them together each time, well, wouldn't that mean that there are going to be 50 groups of 101? So what is the sum of these? Well, that's going to be 101 times 50, or it's going to be 5,050. How does this idea translate into a formula? Express it in words, then write it with the correct notation. Well, I'm going to hit pause so I can write it down so I don't waste time in the video writing my words. Okay, so if we look at this, the idea translates into what we would say in a sentence, well, the first term plus the last term, because he took the first term plus the last term right here, and he added them together. And then he's like, oh, all my groups are going to be the same. So then he took that group that he had from his first term times his last term, and he multiplied that times the number of terms there are. Well, there's 100 terms, but if I group it with everybody else, I got to divide that by 2, and then that's where the 50 terms comes from. So 101 times 50, that gave me the 50/50. If I translated this into an expression, okay, with correct notation, what he really did is he took the first term plus the last term, okay, term number 1, last term, and it's last because it's the nth term, and I don't know how many there are, times the number of terms we call n. N is the number of terms divided by 2, and what that does, that equals the sum of terms for an arithmetic sequence. Wow, that's kind of nifty. Well, let's give her a try here once. So try using Gauss's technique. S sub n. N is how many terms there are, okay? N is not the number term here. This n is how many terms there are. Okay? And what I'm looking at here is if I look at number 1, well, I've got 1, 2, 3, 4, 5, 6, so I know n is going to equal, there's 6 terms there. And if I take the first one plus the last one, because here's my first term and here's my last term, and I take that times the number of terms there are, which are 6, and I divide that by 2, well, what does that give me? That actually gives me 39 plus 4. What does that give me? 43 times 3. And 43 times 3 is 129. And we don't even have to touch our calculator with it, okay? Number 2, we're going to take the first term 12 plus the last term 40. So we're taking the first one plus the last one. And we're going to take that times however many terms there are here. 1, 2, 3, 4, 5, 6, 7, 8. and we're going to divide that by 2. So that's going to give me what? 52 times 4. 52 times 4, that would be 208, okay? Why don't you hit pause and try 3 and 4? Okay, as I did number 3, I'm going to take my first term, 10, plus my last term is 30, so that's where that's coming from, times the number of terms, 1, 2, 3, 4, 5, and 5 divided by 2, oh boy, that's 40 times 5 over 2. If you're going to be intelligent and smart about this, you're not going to call that 2.5. You're going to leave it 5 over 2, because what I can do is I can take 40 over 1 times 5 over 2, and I can cross-reduce that 2 to a 1 and that 40 to a 20 and say, oh, that's really 20 times 5, or a hundo, okay? And number 4 has got a little twist to it. Do you like the twist? Probably not. But I know my first term is 16, plus my last term is 2, and I know I have to take however many terms there are and divide it by 2, but I don't know how many terms there are, because there's a dot, dot, dot in the middle. There could be 100, there could be 1,000. I don't want to waste my time to calculate it all out. So I do know that this is an arithmetic sequence, because they're telling me that's what this formula only works for an arithmetic sequence. And I know a sub 1 is negative 16, and I can also see from 16 to negative 13, d has to equal 3. So if I wrote my explicit formula is going to be a sub n equals negative 16 plus 3 times n minus 1, right? Well, what is n? This 2 is my last term. A sub n is 2 equals negative 16 plus 3 times n minus 1. Notice, I did actually physically plug in the last term. It's n. I don't know what it is. And then what I'm going to do is I'm going to solve for n, and I'm going to add that 16 across. I get 18. 3 times n minus 1. To be honest with you, I'm not going to distribute that 3. I'm going to divide by 3, and I'm going to get 6 equals n minus 1. Hey, that means n has to equal 7. And you know what? That means I have 7 terms. So as I'm cruising and bruising across here, negative 16 plus 2, that's negative 14. That's going to get multiplied by 7 over 2. Don't call it 3.5 because it's harder, because now I can reduce that 2 to a 1, that 14 to a 7, and I can say, oh, that's going to equal negative 7 over 1 times 7 over 1. Hey, that's going to equal negative 49 to get that one, okay? Does Gauss's technique work for both odd and even numbers in terms of, I read that wrong. Explain, does Gauss's technique work for both an even number of terms and an odd number of terms? And all I'm going to say is I'm going to say a big fat yes. Okay, why or why not? Does it really matter why or why not? Because we just did it with an odd number of terms with 5 and with 7, and we just did it with an even number of terms, which is 6 and 8. So yeah, it does work. So let's not break our brain on that. Why does it work? Because it does. Because half of 7 is 3.5, and I can multiply decimals and whole numbers, okay? So what we're going to do is we're going to be looking at a brand new notation, okay? We're going to be looking at a brand new mathematical command, okay? And typing out all the numbers that we had here in a series, okay? If we had our command right here, if this were our command, and we wanted to sum all the numbers from 1 to 7, we don't want to have to be able to list them all out, okay? And this is really kind of a pain in the rump to do. We want a command to tell us to do that, okay? And mathematicians agreed with me for quite some time. So here's our new notation. And this new notation is called sigma notation, named by Euler. Okay, it's called sigma notation, and the reason it's called sigma notation is because this little guy right there, that capital E thingy, as most students call it, what is that E thingy? That is the capital Greek letter sigma, so that's why they call it sigma notation. And there's all kinds of goodies written around sigma. What do you mean all kinds of goodies? Well, on the top, we have a number n. Now please be careful. This n up here, this is not the number of terms. This n up here, that is not the number of terms. It is the last term. Okay? So if my top number is 10, the last number in my sequence is going to be a sub 10. Okay? In this Greek letter sigma right here, what it means is it stands for an S. It stands for sum. Please add all the terms together. And down here in the bottom, I have an I equals 1. Okay? That I equals, this I is called my index of summation. And the index that is down here has to be my variable that is going to be in my sequence command there. You can call that I, you can call it N, you can call it G, you can call it Q. It can be whatever letter you want it to be, as long as whatever letter is there, that is the variable in your command function in there, okay? And then we also have what's called a lower bound of summation. And what this number is going to be right here, that number is the first term that we will be adding together. Okay? And we're not always going to be adding things together. So if I had a sigma like this, where I equaled 3 to 10, I'm actually adding together a sub 3 plus a sub 4 plus a sub 5 all the way to a sub 10. Okay? This is the first term I'm adding. This is the last term I'm adding. And how many terms are there? If you begin at 3 and you go to 10, there would be what? 8 terms. If you finger count them, 3, 4, 5, 6, 7, 8, 9, 10, there are 8 terms that would be summed together. So let's find some sums here, okay? What we want to be able to do is we want to be able to not have to list all these out. So this function right here, this is like my a sub n function equaling 39 minus 7 times n minus 1. But if you notice, they don't have an n there, they have an I. You want to know why the I is there? Because my index of summation is I. And we know if we had to list out all the terms, my a sub 1, all the way through a sub 6, okay, I would be listing things out. Well, what do you mean? Well, if I took a 1 and I plugged it in here, well, that's going to be 1 minus 1. That's 0 times 7. So my first number is going to be 39 plus. Then I take a 2 and I plug the 2 in there, and that's going to be 39 minus 7. That gives me what? 32 plus. Then I take a 3 in there, and I plug that 3 in there, and I take 7 times 2 minus, and the 39, take 39 away from that. That gives me what? I think 25 plus. Then I got to take a 4, and I got to plug a 4 in there for I, and find out what my term is, and that term is going to be, what is that term going to be? 18 plus. Then I got to take a 5, and I got to plug a 5 in there, and that 5 is going to give me term 11 plus, whoa, check it out, there's my last one. That last one goes in there, and that's going to give me plus what? Plus 4. So what this command is doing right here, okay, not to beat it to death, this command is saying, could you please, and it's even asking politely, could you please take all of these, add them together, and what do they come up to? 129. Okay? However, we don't want to have to go through all of this business, do we? No, that's too much work. So how are we going to do it? Well, here's how we're going to do it. Whoa, didn't want to do that. I'm going to try to get this out. Okay, so I'm just going to erase them and start this. And what we're going to be doing is we're going to be using our sum of the n terms is going to equal, we want the first term plus the last term times the number of terms divided by 2. Okay? That's what this is telling me to do. It's saying add all 6 of those terms together, and it's actually all 6 terms. Okay? So what I'm going to do is I find my first term by taking this first one, plugging it in there, and 39 minus 7 times 0, that gives me 39. So that's my a sub 1 term, plus my last term, that's taking the top up here and plugging that in there. And when I take 7 times 5, I get 35. 39 minus 35, that gives me 4. So that in this case is my a sub 6 term, okay? And that's what I'm doing, times, I don't know how many there are, but I need to divide them by 2. Well, you can finger count, or you can do this the logical way. If 6 is my last term, minus my first term is going to give me 5 terms. I'm always going to have to add 1 to that to get 6 terms, okay? And I have to add 1 to make sure so I include the first one I started with, so there will be 6 terms that are there. Now, what am I going to do? Is I'm going to do my math, okay? And 39 plus 4, 43, times 3 gives me what? 129. 129. That is the sum of all 6 integers, okay? Why don't you I'll walk through one more with you here, and then I'll have you do one on your own, okay? So what we're going to do is extend my page up. We want to find the sum of the n terms, okay? Sum of the n terms by taking the first one plus the last one times however many there are divided by 2. This n is different from that n. They are not the same thing. The thing on the top of the E thingy, on top of my sigma, okay, on top of my sigma is talking about the 8th term, okay, not how many there are. So we're going to say, I need my a sub 1 term. My a sub 1 is going to get my bottom limit in there, and I'm going to say 1 minus 1 is 0 times 4 is 0, so my first term is 12, okay? I need my last term here. I find the last term by taking that top number into my function, and I'm going to say, oh, that's going to be a sub 8 equals, and I got to say 8 minus 1, that's 7, times 4 is 28, plus 12 gives me 40. So I know I got to take the first one plus the last one, and I got to multiply that by how many there are divided by 2. Well, how many numbers are there from 1, 2, 3, 4, 5, 6, 7, 8? There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 terms. Notice I said always take top limit minus bottom limit plus 1. These two kind of cancel it out. If your bottom starts at 1, the top number will be how many there are. However, be careful, okay? And I'm going to get rid of that for a second. And what do we get here? We get 52 times 4. What is 52 times 4? 208. Woo-wee. Why don't you try the last 2 here quick, and I'll be back. Okay, so if we went through, we want to make sure we find our first term plus our last term times our number of terms divided by 2. Okay, so what I do is I take my lower limit and I plug that in. That's my n. So 25 minus 3 times 1 minus 1, that gives me 25. That's why that's there. The last term is taking my top limit and plugging it in there, which is 25 minus 3 times 10 minus 1, which is going to be negative 2. That's why that's there. How many terms are there? There's 10, because if I take the number of terms from 1 to 10, there's 10 terms if I add them all together. So I get 23 times 5. That sum equals 115. Notice the summation of number 4 is a skosh different. My first term is plugging a 1 in, which is going to give me 7 plus 2 times 1, or 9 is my first term. And the last term is plugging a 36 in there. Well, that's 7 plus 2 times 36. That gives me the last term of 79. And from 1 to 36, there's 36 terms. That's why I want to say top minus bottom plus 1, and those get rid of it. So I have 36 terms. Divide by 2, it's 88 times 18, 1,584, okay? And the last thing we're going to do is we're going to go back here, and we're going to do a challenge, because you're going to have to be able to do this. Challenge, go back and write them in sigma notation, okay? And I'll explain that, and we'll be good to go. So first thing in order to do, number one, we're going to have to be able to make a big old sigma, okay? And what I would do a lot of times is, well, I need to know what a sub n is going to be. Well, it's my first term plus, what is between there? What is that? That would be 7, right? Ooh, it's not plus, it's taking away. Okay, so it's minus 7 times n minus 1. So that's my rule, and my rule goes here. Okay, and notice I have an n there. So my first one is going to start with n equals 1. Notice I made my index the same as a variable here. I can make them i's if I want. And then my last term, there's 1, 2, 3, 4, 5. There's 6 terms. So I'm going to put a sub 6 because that's my last one on top. And that would be my sigma notation. Why don't you give 2, 3, and 4 a quick try? Okay, remember, we want to do our sigma. If we want to write in sigma notation, we need to make a cute little sigma. What always goes on top of the sigma up here is 1, 2, 3, 4, 5, 6, 7, 8. That is a sub 8. The 8 goes up there on top, okay? Now don't confuse, that's not the number of terms. That is going to be my 8th term, okay? And I know I'm going to start it at 1, but I know here I need my rule that finds all of these, and I can say a sub n equals my first term plus, well, between 12 and 16 I went up 4 times n minus 1, and I can take this rule and I can put it in here of 12 plus 4 times, and I can call it I minus 1. Let me get rid of this. I did that. I don't like that. I minus 1. And I'm going to get rid of this guy. And please understand, if I use I here, I have to use I here. And I'm starting at a sub 1, and I'm ending at a sub 8. That's why the 1 goes here. The 8 goes here. My rule goes here. That is sigma notation for number 2. And I'm just going to actually have you do the last 2, and I'm just going to write them up there here in a second. And there's the last 2. Please don't get confused on number 3, where I put my index of my summation as j. Okay. Up here, I wrote my sequence in terms of n. I can make that variable be whatever I want it to be in here. As long as that matches that, I am good to go. And number 4, you actually had to calculate your last term because all the dots in the middle. And I did that right here. And then I took my last term number, I took my first term number, and I wrote my rule, and I wrote my sigma notation. So you guys should be able to, I know you can do numbers 1 through 4 on your 2.8 try on your own, and we will finish up this section tomorrow, and enjoy life, and hey, thanks for playing math today.